Trervor Kelly. We'll talk about mine water opportunities in Nova Scotia in Canada. Hi, Trevor.
Right. Hello, everyone. So I'm going to present some work here on mine water geothermal opportunities in Nova Scotia, Canada. So a lot of the focus of this work will be on Spring Hill, Nova Scotia, which has been a mine water user for close to 40 years now. So yeah, we're on the east coast of Canada. Spring Hill itself is located in Cumberland County in northern Nova Scotia. Relatively small population of less than 3,000 people. And at one time, it was one of Canada's most commercially important coal fields. So if we look at a Carboniferous reconstruction map from Ron Blakey, Spring Hill would have been located roughly here between the Caledonia and Cobequid Highlands. And if you look at this figure on the left, you'll see the present day location of Carboniferous basins. So those are the gray areas, and they are significant because those basins do contain substantial coal measures, of which Spring Hill does contain a significant quantity of coal. So a geological map is shown here on the right. So a lot of that geology underlying Spring Hill pertains to this gray unit, which is known as the Spring Hill Mines Formation. So it's composed of kind of sandstones, mud rocks, and of course, lots of coal. Thickness is approximated at 700 meters. And if we draw a cross section through that, you can see that gray zone there, you'll see all the major coal seams in Spring Hill labeled. In actuality, there's upwards of 50 to 60 coal seams in the Spring Hill Mines Formation. They range from centimeters to meters in thickness. So with those coal mines, of course, came the development of numerous coal mines. So you can see here the footprints of those coal mines, and they're kind of stacked on top of each other because they were mining different coal seams. So the largest being the number 2 mine, which is outlined there in orange. So the surface extent of that mine is upwards of 4 kilometers, and the depth reached in excess of 1,250 meters. And then just a couple images there on the right of some of those mine workings that were imaged using a downhole camera. So yeah, the number 2 mine is by and large the largest coal mine in the Spring Hill area. So with that, of course, comes the sort of heating and cooling capacity, which for the number 2 mine is fairly significant. And that has to do with the fact that nearly 11 million tons of coal was extracted during the lifetime of that mine. So yeah, it's an excellent source of mine water. And certainly when you add in the other coal mines in the area, yeah, there's some substantial heating and cooling capacity to be had. In terms of the natural recharge rates, so the number 2 and the number 7 mine both had measured recharge rates, and I was able to loosely calculate the remaining recharge rates for the other coal mines in the area. But roughly speaking, we're looking at a natural recharge of the system of approximately 54 liters per second. In terms of mine water volumes, the most recent calculation of mine water volume for the number 2 mine was back in 2006, estimated at roughly 5.6 billion liters. And again, if we factor in those other coal mines, that number grows to in excess of 10 billion liters of available mine water. So yeah, there's been a lot of work done in Spring Hill over the past, nearly 4 decades. So initial drilling commenced back in 1987 with ROPAC. So they're a plastics manufacturing facility, and they are still a user of mine water to this day. In 1989, some wells were drilled for Surette Battery. Again, they continue to be a user of mine water to this day. There's been lots of other companies and facilities that have used mine water as well. And if we go into the early 2000s, the construction of a community center made use of the available mine water. The Nova Scotia Community College uses mine water for heating and cooling of a laboratory. And most recently, last year, the construction of a new fire station saw the drilling of a supply well. So, yeah, lots of work still happening. And this here just shows the spatial distribution of all those geothermal boreholes that have been drilled in the Spring Hill area. So targeting different coal seam workings, variable depths. And within kind of the drilling of those boreholes, there's also been a fairly substantial amount of temperature data collected. So if you look, you'll see some fairly elevated temperatures here at very shallow depths. So those are probably not considered to be too reliable, as a number of those measurements were taken during the process of drilling. So yeah, it's not known sort of what kind of caused these extremely high elevated temperatures at very shallow depths, but they are raw temperature data, so they haven't been corrected or anything like that. These points here that are labeled with the trend line, those refer to a coal bed methane exploration well that was drilled very close to the mine workings. And those really form the basis of our knowledge of the geothermal gradient of that area. So that borehole reached a depth of over 1,100 meters with a temperature of approximately 28 degrees bottom hole. And if we take that coal bed methane exploration well and we sort of map out the geothermal gradient on the number 2 coal seam, we kind of end up with this type of a map. Of course, the benefit of mine water is that you can get warmer water at shallower depths. So yeah, shown here being the number 2 coal mine. Recently, there's been a lot of work done on a mine water geothermal greenhouse for Spring Hill. So a geothermal greenhouse has been mentioned as a possible user of mine water geothermal by no fewer than 3 consulting reports over the past several years. So with that, a geothermal greenhouse action plan was initiated, and it is sort of in the final steps of being completed. There were 3 scenarios that were looked at, so a small, medium, and a large greenhouse. And it was agreed that the medium-sized greenhouse was sort of the option that checked all of the boxes. So with that, we kind of assessed a couple different drilling scenarios for this mid-sized greenhouse. We looked at drilling a shallow well between 230 and 280 meters depth, where we expect water temperatures to be on the order of 12 to 18 degrees Celsius. We also looked at drilling sort of into the toe of the number 2 mine at a depth of 1,200 meters, where we expect 28 degrees Celsius based on that coal bed methane exploration well. And yeah, just sort of a rough site plan, I guess you'd say. So the greenhouse being shown here, it is on municipal property. An extraction well would be drilled into the number 2 mine slope, and then a return well drilled close to the vicinity of the geothermal greenhouse. In terms of the overall potential for Nova Scotia, so we have two maps here showing the heating and cooling capacity. So there's 3 regions, really, 3 counties where we see the most potential for mine water heating and cooling. Number 1 would be Cape Breton. So these would be underground coal mines. Pictou County, again, underground coal mines. and Cumberland County, so where Spring Hill is located, and these are also underground coal mines as well. In terms of the available information, well, we've got in excess of 50 reports that have been written over several years, several decades actually. We have 100 mine plans, cataloged, digitized. We're working on presenting some of this geothermal work online for the public. The action plan should be available online shortly. And if anyone has any interest in sort of a comprehensive overview of geothermal resources for the onshore Nova Scotia, they can visit this link here. And it's a very comprehensive report done approximately 5 years ago. And yes, with that, I'd like to thank my colleagues Mark DeCamp and Chris Sangster for helping me put this presentation together. And thank you to the organizers and hosts of this symposium. It's great to sort of bring together the mine water geothermal community. So appreciate that. Thank you very much.